extremely high. Now we have a, let's say, countdown issue in the evening that we're going to provide. But first of all, I want to introduce Mr. Stephen from Tottenham. I think you all know the game that they played and the awards that they wanted to give. And I would like to ask Mr. Stephen from Tottenham, our sponsor, to come up and please tell us or sort out who the winner is of the play today.
Louder!
The drawing is our trainee research and development document, and we are going to draw 3 iPods. First, the winner of the iPod shuffle is.
This is Tim Aschberg. Are you here? Tim Aschberg from Kiel. Oh my goodness. Okay, you will get it by post.
And the second winner is.
Catherine, was hast du jetzt schon alles in Richtung hochgebracht?
Jones Kyle from Canada. Canada, not here? This is Michael Baske from Kaiserslautern.
Okay, thanks Mr. Singman. Please give him a hand for supporting the Formula Student Germany event and especially for supporting us next year. That's good because this is almost done. Now we're coming to the engineering design review, and I would like to introduce our 3 chief design judges who have been judging you, and I think this is probably the best ever prepared design review you will see, so it's really worth looking at it, learning from it, and I really would like to introduce first of all Pat Clark from Australia, Steve Fox from the US, and Woody Kitchen from Germany. So, please, I just hand over to you guys. Then we'll just get you more advice and things we can do about the design. Thanks.
It's already on. That's how you turn it on. I can't find a switch. Good day, Pat. Good afternoon, Stephen. Good afternoon, Ruth. Hello, welcome all. Standing room only down the back, I see. Okay, in the past we've tended to do design reviews at the end, or design reports or whatever at the end of the event in an ad hoc manner. This time we've decided to do it a little bit different. We have a PowerPoint display to show you. We have a theme which runs through, and the theme which will run through this design is the old saying that he who doesn't learn from history is bound to repeat it. One of the things that the judges see again and again and again is that the teams make the same mistakes. You know, the new teams can make the same mistakes. And they actually make mistakes which have been proven in the past in history to have been many years ago. Okay, I'll get it started with a couple of PowerPoint slides which are text type slides which will basically tell you what we're going to talk about tonight. And then we'll start to get maybe a little bit funny. So this is the design review adventure. To see several of us. We will invite guests to speak on occasions. Okay. Steve is big on this. Steve runs his own business. He knows about running business. He knows about planning. You want to run through some of these things, Steve?
Sure. You all built the Formula Student Germany car and showed up at the competition with it. You all think that it was a pretty big goal to achieve this. What you really did was you did the first really big project of your young careers. And just like any big project, it starts with goals. The first thing that your team should set is goals, objectives, and strategies. Simple questions: 4 cylinders, 1 cylinders, handling speed, pull rod suspension, push rod suspension. What do I do? The first thing you do is you read the rules. Understand the rules, then you reread the rules again and really understand the rules.
How many cars didn't get through scrutineering first up? If you'd read the rules and obeyed the rules, you'd have got through scrutineering first time.
Absolutely. As Pat's already said, those who don't learn from history are doomed to repeat it. We are going to go over some history type stuff in this design review, and I hope you'll all find it very interesting. Most of all, I hope that you all learn a lot from it. Project management is very important to this kind of a project, and design reports are actually very easy if you know the secret.
What's the secret?
The secret, Pat, is there is no secret.
Innovation. What's innovation?
Innovation is true design. It's the origination of an idea or a concept. In Formula Student Germany, we're going to introduce you to the fact that we don't think there's a lot of innovation here. What we think there is clever design.
And that's the sort of innovation we like to see.
Tires are the first thing that you look at from a design standpoint.
Who disagrees with that? All your acceleration forces, forward, backward, sideways, all through the tires. You have 4 patches the size of the palm of your hand. You got to make the most of them.
After you've decided on the tires dictate what the suspension looks like. Then you do your suspension design. The suspension is designed before the chassis. There are an unusually large number of teams that don't understand this simple concept. Right after you get the suspension design, the chassis is a fall-together deal because all you do is you connect the dots. Wherever the chassis mounts to the suspension, that's where the chassis points belong.
Okay, we're talking about making it go. How do you make it stop?
I think that's those round things, the brakes, right?
Them's the brakes.
Brakes should be designed for the best performance, and not necessarily the lightest brakes, but the best performing brakes.
How about the engine? How important is that?
It's pretty important, but I gotta ask you, Pat, is this a handling competition or is this a drag race competition?
Well, obviously, it's an exercise in physics. You've got to get your motor car from point A to point A 20 times in a row, and it takes energy to do that, and that comes from the engine. But the efficiency of using it, I'd put the split at about 30-70, power to handling, engine to handling.
Oh, really?
Your thoughts?
You've heard of this thing that's called F equals MA?
F equals MA.
F equals MA.
That's that old bloke. What was his name?
Murphy.
No, not Murphy. Not Murphy. Murphy's somebody else. We'll talk about Murphy later on. No, seriously, engine is important, but not as important as some teams seem to see. And one sad thing that seems to happen is that sometimes we see the engine gurus take over a team to the detriment of the overall picture, because they must handle, these things must turn, they certainly must put the power on the ground. Power is important, handling is more so.
Handling is more important.
Okay, how do you put this power on the ground?
That falls to that chunk of stuff behind the engine called the drivetrain.
Would that include the chain?
Sometimes. Sometimes the chain falls off, and that wouldn't include the chain.
I'm sorry, Stuttgart, I couldn't help that. How about ergonomics?
Ergonomics are important, and basically any race car that you design should be designed so that the driver can literally fall asleep in his racing seat. If he has to worry about what's poking him in the sides or in the legs, or if the steering effort is too high, he has to concentrate on all this little stuff, and it's going to keep him from driving the best laps that you can possibly extract for that car.
So are you saying that a tiny little steering wheel like off a Game Boy is not really a good idea after 20 laps?
Not after 2 laps.
Not after one lap.
Well, if you've got Arnold Schwarzenegger arms, maybe the little steering wheels are good, but most of the students here are not built like that. So they need more normal sized steering wheels.
One thing I've got to bring to your attention though is, I thought this competition was about building a prototype for production. Don't they have to theoretically manufacture 1,000 of these things?
Theoretically.
So, should it be easy to make?
Oh, it should be extremely easy to make.
Should it be easy to fix?
Absolutely. Of course, I'm sure that most Formula students don't fix their car at the competition. They never break, right?
Never break. Do you read what's on the back of the ticket when you go to a motor race? What's it say? Read the back of the ticket.
I don't read.
It says, of course I read. I read the dots. On the back of the ticket it says motor racing is dangerous and you're here at your own risk. Is motor racing dangerous?
Inherently.
So therefore should we take into account that safety in this issue is a big deal?
Absolutely.
Do we want to hurt people?
Safety is the biggest issue out there.
Yeah. And yet we see cars that are going to break the driver's legs in a bad crash. We see cars that are going to punch holes in people. We see all sorts of nasty things that we don't like. And we're going to get tough on that. Talk about the goals.
Time and time again, I ask a team, what is your goal? Is your goal to show up? Is it to compete? Is it to win design? Do you really just want to win endurance? Or do you want to be the overall winner? What kind of drive does your team have? I usually don't take a team very seriously when they say they just want to show up and they just want to drive.
Is it a fair goal just to show up?
It's a great goal to show up, but it's an even bigger goal to win. Aim for the top spike.
So if you have $200 to put a team together in Nicaragua and you don't have an engine, would a reasonable goal be to come here and win everything?
Probably not.
So you have to set your goals according, what do they say? Cut your cloth according to the price of the material.
Absolutely.
Every team must have a goal.
All teams operate at different skill levels. Smaller teams should have fewer goals. Larger teams can do bigger goals. The skill level of the team also is very important. And usually the bigger teams with the higher skill levels are the ones that you see really going over the top of the show with.
Yeah, we often see situations where a little team design and build a little car, and then they get waylaid by some team member who wants to design some electronic gadget that takes up all the time and then they just don't make the event. You have to set your goals according to your abilities and the materials that you've got.
Absolutely.
See that thing down the bottom? If you fail to plan, you
Plan to fail.
Write that down in your head. If you fail to plan, you plan to fail. First, words of wisdom. Okay, a theme will run through this presentation. We talked to you about that. The philosopher George Santayana said a lot of things, but one of the things he said that those who don't learn from history are bound to repeat it. The design judges are amazed each year by the mistakes that they see repeated again and again. And a classic example of that is the dreaded rod ends in bending. Now, who doesn't know about rod ends in bending? Who actually brought a car to the competition knowing they had rod ends in bending, knowing they shouldn't, but thought, it'll be right? This guy did.
Oops.
You know the happy look on his face? Okay, engineering history. Those who don't learn from history are bound to repeat. Here we have a 1920s Model T, front suspension has collapsed when it's been braking and has fallen on its face. And here, 80 years later or something, we have a Formula student car in the UK which has done exactly the same thing. Those, I won't say it, you know it. Okay, don't set unrealistic goals. We talk about this. Obey the rules. You don't obey the rules, you get busted.
Read the rules and reread the rules.
Example, what's wrong with that? It's a karting suit.
Thank you.
Somebody came to an event with a team kitted out in $600 karting suits, sent away from scrutineering, waste of money. Okay, what about this one? You have to have a crushable headrest behind the driver, don't you? Not behind the sheet metal. Read the bloody rules. There's a rule about seatbelts, isn't there? Read the rules. These things you won't get stuck in scrutineering if, by the way, people are trying to take pictures of this. We'll make it all available, so okay. Okay, some history. This is talking about your expectations, cutting your cloth according to what you've got, and so on and so forth. We have here a small story, two history stories. This car is a small team, first year car in 2003. They built a simple little space frame car, 450cc engine, simple EFI, wheels. The result, nothing special. They finished 9th on debut after they took a time penalty in the Enduro. But it's like tipping a rock off the top of a mountain. What happened? That happened. Welcome to RMIT. There's 4 wins in 4 events in about 4 years, and heaven only knows how many seconds and thirds. That's a team that started off with a realistic goal and built from the bottom up, didn't overextend, weren't over-enthusiastic about what their opportunities were, and they've turned out now what we'd all agree is one of the very best cars in Formula SA or Formula Student all over the world, full stop. Okay, now let me give you another example. This is the car from the University of Auckland. Small team, 2005. Carbon chassis, ground effect, aero, supercharged and intercooled. Re-engineered the engine so it rotated backwards. Custom alternator, dry sump, custom transmission, carbon electronic steering wheel, telemetry. What happened? Couldn't compete because they just weren't finished. Project management, hugely important from day one. A wonderful car, a beautiful effort, you can see it looks fantastic, but it's a rock, it just sits there. Okay, another issue. 10 years ago, a team turned up in the US with this chassis. Okay? They had that suspension and brakes bolted on it. We can talk about that if you wish. That is so horrible it's not funny. And they had this masterpiece of an engine bolted in there. They made their own V8. Okay? They made their own V8. Did they get started? No, they did not. They cut off far more than they could possibly do. And in the words of the late great Carl Smith, the race starts at 3 o'clock, and if you're not there,
That's okay. The race still starts at 3 o'clock.
and let's remember Carl, one of our mentors.
That team did a great job on the engine, but they didn't have a starter on it. It did not self-start.
Read the rules.
Read the rules.
Okay. We spoke a little about this. Handling your speed, tube chassis, composite chassis, hybrid, 10-inch wheels, 13-inch wheels, pull rod, push rod, all these decisions have to be made. Which type of fuel are you going to run? You want to run E85? What do we know about E85? Conventional transmission, CVT, are you going to take gears out of the transmission? All these decisions have to be made, and if you haven't got the wherewithal or the ability to do this and manage this, you just can't do it. So you have to plan your project according to the tools and the people and the staff, and more importantly, the money that you have. Is money important?
Money?
Money?
Doesn't
Preferably other people's money.
Yeah. Remember, don't use your own money in racing. Go find a sponsor and use the sponsor's money.
Okay, so how do we get on the winner's podium and still be friends? Like this group. They're all friends, aren't they? They're all best of friends. Don't think. I looked hard for a slide that would illustrate this, but how do you do that? It's actually very difficult.
It is actually very difficult. This kind of goes into psychology. In order for you as a team to stay friends, you have to choose a reasonable workload. You all have to delegate the responsibilities of constructing this car out equally amongst the team members based on their skills, and not overload yourselves. Set reasonable goals for the number of people that you have and the skill level and the resources at hand.
Okay, where does this all start? You know, the first thing that we see from your car is a design report. You're supposed to put in a report, 8-page report, 4 pages of text, 3 sets of line drawings, and an additional view. Got to tell you, 78 we read.
Yeah,
How many good ones?
3 or 4.
If being
Really,
charged.
really good ones, yeah.
Now we spoke about this last year, and I'm going to tell you again. What is the design report? The design report is a briefing document from one set of engineers, you guys, to another set of engineers, us guys, the judges. It is not a marketing document. It's not a flossy sales document. It's supposed to be a straightforward, factual document that you submit from one set of judges or one set of engineers to another. And you just don't bloody do it. I don't know why. We talked about this last year. But how do you write a report? What's the trick?
What's the secret to a good report, Pat?
There is no secret
There is no
to a good report. First thing I'll tell you about a good report is remember that a picture is worth 1,000 words. I put one picture on the screen and you can tell me an awful lot about that motor car. You can tell, for instance, that it's got a carbon chassis with the engine inside. It's got triple spring suspension, it's got pull rods and push rods, it's got this, that, and the other. You can tell an enormous amount from that. So can we. And let me tell you that after you've had a whole bundle of design reports to read, you start looking at the pictures, because that's often where the information is. Okay, there are supposed to be 3 view drawings in there. What's a drawing? What's not a drawing?
I'm not sure this crowd knows what a real drawing is, because I doubt any of them ever had to sit in front of a drawing table with a pencil and a T-square. But in reality, a drawing is a sketch of your car. It's not a screenshot. It's not a color photo. It's not a colorized photo. It's an actual drawing that looks like you drew it with a pencil.
And nothing gives us the poos more than a low-resolution JPEG screened up from a solid modeling program with no detail to be seen. Drawings look like this. Chose this car particularly because this was Danny Doyson's car. You around, Danny? No, he's busy, probably cleaning up. Daniel Doyson, who was running the event. This is a car from there, so here's the front elevation, plan view, side elevation. Some dimensions, but not too many, but certainly enough for us to be able to look and see how this darn car works and how things happen. What about the illustrations though? Sometimes an isometric view or even a colorized drawing might be good to illustrate other things, you know, so there's an illustration which tells you a lot about the car.
This type of an illustration is strictly optional content.
Absolutely, this is not your 3-view drawing, but it still tells us a lot. We like this. There's another option on that, that's the same car from the other end. How much information do you think we could figure out about this car from that drawing? Lots.
Do I need to read 2 pages of text, or can I just take a glance at this and tell exactly what this team has done?
Down here. Okay, in this case, this is from the same car. Would not a photograph have been better here? Why is the drawing not a good idea here?
No detail.
And how the hell do we know they ever tested it?
Exactly.
If that was a photograph, we know they've actually done some torsional testing. Okay, just for balance, and just so you don't feel so bad, I'll show you the worst drawing we've ever seen. Not joking, Claude was there. Where are you, Claude? Yeah, you were there, weren't you? You think that's bad? How about this? That's like...
Now that's a drawing. There's no screened up there. Or there.
I love those eccentric wheels. Okay. So what is this trick to writing a good design report? The design report, as I said, it's not a marketing document. It's a briefing from one set of engineers to another. And the way you write it is one of 2 ways. First thing is, when you start off at the beginning of the year, and you have meetings to plan your design, so you're going to sit down, you're going to work out whether you're going to have 10-inch wheels or 13-inch wheels, whether the car's going to be front engine or rear engine. You have these meetings. You do keep minutes, don't you? You keep minutes and records of your meetings? Don't you?
Of course they do.
No, they don't.
These are college students, Pat.
Yeah, okay. when all those design decisions are made and recorded, you then give the whole thing to a journalism student or a journalism major and have him put it into a nice readable document. You know, with journalism, it's one of those old skills doesn't go away. We've got standing here falling asleep in the front. You're a journalist, aren't you? This is Alan Staniforth, one of our other great old mentors. Okay. One other thing about it is, for heaven's sake, don't waste the space. You don't need a fancy front cover. All we need to know is who you are, what's the number of your car, and what the competition you're entering is. Because another thing that we don't like is somebody puts up a design report for a car from Formula SAE Italy. This isn't Formula SAE Italy, this is Formula Student Germany, and your paperwork should relate to that, as should your specification sheet. Put your spec sheet, your specifications on the correct master sheet. We don't like it if we don't, yeah. Okay. Do nots in design reports. Go on, let them have it, Steve.
It's such a big list of do nots. It ran way over the page, but we weeded it down. Don't patronize the judgments, the judges. Statements like, we all know that composite chassis are best will not get any respect. Okay? We all do not know that.
We had a bit of a talk about this the other day, and we agreed that the worst patronizing statement we had in recent history was the team that told us that, as we all know, the tires connect the car to the road.
Honestly, it appeared in a design report. As we all know, the tires connect the car to the road.
Don't use words like optimized or perfected or whatever. We don't know what the optimum is. You don't know what the optimum is. We don't know what perfect is.
Statements like, I don't know because the student that designed this graduated, is the kiss of death in design judging.
Goodbye.
If you do not know the information, don't even try and present it.
Don't base your designs on the demands of a sponsor. A sponsor gives you some concrete tires and says, here you are, go racing. You're dead from the outset.
But Pat, they were free tires. They were free. We're on a budget. We don't have money. They were free tires.
And they gave them T-shirts to go with them.
Yeah.
Yeah, okay. Finally, the big one, for heaven's sake, never, ever, ever lie or BS to the judges. We've got this very well-developed BS filter, and you don't get very far. Okay, what about this thing called innovation?
True innovation is at the scientific level. It's not really at Formula Student Germany level. Now, I'll qualify that statement. We have seen some very interesting and unique new ideas, but for the most part, what we see is clever design.
Is innovation doing something new? Yeah. Claude in his youth designed and built a Formula Ford car. So did this guy. Is that an innovative car? Or is it just a blind alley because it was made different for different sake? Should it be that that body shape much better suits a land speed record car? Do we still see Formula Ford cars like that? Nope, so it wasn't innovative, it was in fact a blind alley. What about this one? Is that an innovative design? Now, before you comment, I'll ask you to stop and think. We have a whole new set of rules next year about foot space, don't we? Okay? A car like that allows you to put the driver back beside the engine and clear the foot space and maybe make the car a little bit wider might make it much easier for you to pass it might be an innovative solution to passing the rules. Does anybody know how old that car is? It might be 88 perhaps. Yeah, that looks like 20 years old. What about that one? This is a team that took a Formula Ford car, put it through the dryer on hot, and shrunk it. It's a 7/8 scale replica of a Formula Ford car. The people who designed it knew nothing about the design, they just made the car smaller, figured smaller truck, smaller car. It didn't work. They didn't know why it didn't work. Even if it had worked, they didn't know why it would work, and it's not innovative and it's not successful, and that's a waste of time. What about this? I'll give you a moment to study the picture. Anybody know what they're looking at? You're looking at a DD on a rear axle. Those who don't know what a DD on a rear axle is, it's an axle that connects both cars together. So successful on Maserati 250s in Grand Prix racing in the 1950s and so on and so forth. Is that an innovative design? We have, maybe there is such a thing as retrospective innovation. Remember this business about learning from history? We have a very respected design judge in Australia, Ron Tornak, who's the Brabham and Rolt designer and probably the most successful race car engineer of all time, who looked at that car and said, I made that mistake once, 50 years ago. What makes this even worse is that this car has a live aero. The wing load is fed directly down into the uprights, and the wing is then captured in 2 points on the roll hoop. So as this car rolls in a corner, the rear airfoil becomes the world's stiffest rear-end roll bar. Did it work? Nope. Did it look pretty with all the engineering and all the fancy fitting? Yep. Is it innovation? You tell me, is that innovation?
Nope, not innovation.
What about that one? Lehigh car from the US, they built a whole lot of them. Okay? I have several pictures of this with the chain lying on the ground beside it. And let me tell you, nobody took it off. Stuttgart will tell you what that happens. It's not a very good feeling. What about that one? Yeah, if you're interested, Concordia, yes. If you're interested in old Morgans with sliding pillar suspension, you might be interested in that. That's just different for the sake of being different. What about this one? This is a car from the Michigan competition, sponsored by one of the car manufacturers. And somebody said to the students that McPherson struts would be a really good idea on the chassis. No, they are not. McPherson struts are a cheap solution to building motor cars that don't really work very well. If you plan to do something weird, you got to really, really, really be ready to defend it. Now, do you think if the judges look at this car and they say, I don't like it, therefore I'm going to mark it down? Nope. Because if you do a really good defense on your design, you'll get a good score. It's not our opinion that matters, it's how you have defended your design that matters. We might know it won't work, and there's another competition out here that shows whether it works or not. It's called the endurance. And we may well say, told you so, but in design, your job, it's not what you've done, we can see what you've done, it's how you defend why you did it. Why did you make those decisions? Why did you make that compromise? And it may well be that one of the car companies gave you $100,000 in sponsorship, but one of the conditions was that you develop or design a McPherson strength car. Okay, we're going to talk about some project management, and I'm going to tell you a little story. I'm not going to ask Alan because he's from that generation, but does anybody know who those two gentlemen are? The man in the blue and the man in the car?
They're all too young, Pat.
Incidentally, is there anybody here from Tokyo Denki? Anyone here from Tokyo Denki?
Tokyo Denki.
There is a fair chance that this might be our Dr. Sano. The man in the car is Jack Brabham, 3 times world champion racing driver. The car that he's sitting in is a Brabham racing car. Innumerable championships. 4 world championships. The only time Mario Andretti ever finished the Indy 500 was in a Brabham design car. Anything worth winning won by Brabhams. The gentleman in blue is the aforementioned Ron Tornak. Run about 4,000 production racing cars, innumerable championships, both as Brabhams and Rolts and other things. We're very fortunate to have him in Australia as a leading design judge. He's a little old these days to come up here, but he would love to come to this competition, and maybe if we can persuade the organisers to put him in business class or something, maybe we'll get him here one year. Very, very nice old man, but a man of few words, let me promise you. I think Stanley had to interview him once. Could you get 3 words out of him? Stanley says a brilliant talker in the cab rush into the airport. Okay, the reason why I've got him up there is Ron Tornak ran the most successful race car business with good management. How he did this was in the design stage, he involved his employees and his designers and whatever, and then when they reached the time ready to production, he would drive a peg in the ground and that was the end of it. There was no more discussion until the next design stage. In other words, he drove the team forward. In fact, his name is Toranak, but the guys in the factory call him Anorak, because an anorak is always on your back. Push, push, push. You need a leader like that in your team. Project management, you need him to be open to discussion and to input up to a point, but if you start faffing around with the design once you're building the car, you lose. You have to decide where you're going and get on with it. Anything after that's in the next design. Okay, some people are born leaders, some people are followers, and some people are just along for the ride. And every team is the same. You can see here who is the leader, you can see here who is the follower, and you can see who's just along for the ride. Agreed? That's the way life is. Okay, over to you.
This gets back to good project management and the psychology of getting along with your neighbors. If you guys are working together as a team, you all have to pull together just like a dog sled. Everybody has to pull in the same direction. If you don't, what happens? You end up with what I refer to as a cat sled. If you hook a bunch of cats to a sled, what happens? They all go in different directions, don't they? And you get a bunch of people trying to herd them up, gather them around, and it wastes a lot of energy. And you don't achieve the goals in the time that you set.
There's another thing to take notice of is that you have here your leaders and your followers, but you notice how many dogs there are. You notice how many cats there are. You notice how many managers there are for the dogs, one. You notice how many managers there are for the cats trying to keep it under control. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to try and keep the cats herded. And you also notice that in this slide that the sled is actually moving. The sled isn't actually going anywhere. So, question you got to ask is your team a dog sled team or a cat sled team? And if it's a cat sled team, fix it. Okay, tires. Most important decision you make in the whole car is the tires, you know? You need some race slicks like this, don't you? For race slicks. And you need suspension like that too, I guess. Okay. Claude's thoughts. Claude's company, Optimum G, has a mission statement. There's the mission statement. It says race car performance is not only about maximum lateral acceleration, it's also about longitudinal and vertical acceleration. It's about maintaining at every position on the track the maximum possible grip. That means maintaining the maximum directional acceleration in the appropriate direction and creating the ideal yaw acceleration at any corner position. It's about optimum acceleration, the Optimum G. And this has been a gratuitous plug for Claude and his company. We're presenting a seminar here over the next 3 days. And for anybody who isn't going, there are, I think, still, Claude, where are you, Claude? Still 1 or 2 openings? Okay, bring your money with you. What's the cost? I'll go to the Optimum G website and, okay, never too late, an unmissable thing. I think we've got about 60-something people enrolled so far, but go on, say a bit.
It's over 60. There's very few slots left. If you want a truly dynamic 3-day experience with chassis and suspension and optimizing the G of your race car, this is the seminar for you.
End of gratuitous plug. Okay, is your team a member of the Tire Test Consortium? Anybody not a member of the Tire Test Consortium? How much does a set of tires cost? What, 500 euros? How much does the Tire Test Consortium data cost? 300 euros? Anyone who's not a member of the Tire Test Consortium, join it, because it's information available there that's just not available anywhere else, anywhere. Not even in Formula One. Put a picture up there. Every tire tells a story. Have you noticed the judges walking around, laying hands on your tires, taking pictures of your tires? we can tell about the heart and soul of your motor car from looking at your tires. You should be able to tell about the heart and soul of your motor car looking at the tires. Tire choice is critical. Ask Oxford Brooks. Oxford Brooks people here? Okay, they had an issue a few years ago where their tires fell to pieces. Pardon? Oh, well, I would guess so. But was it all the tire's fault? Was it all the tire's fault? Pressure issue? Chassis stiffness issue? The best of tires are no good to you if your chassis is not set up to make the most use of them. A well set up car can win on the second best tire. A poorly set up car cannot win on the best tire. Okay. Those who don't learn from history, we're back to that theme. Wheels can break, and they do. We see some terrible wheels, I've got to tell you. Even here we've seen some dodgy wheels. Some years ago at the UK, a team turned up with this set of wheels, and the judges looked at them and we said, we don't like those wheels. They're GTB. What do you know what GTB means? Tell them.
Going to break. GTB.
GTB. No, they're not going to break. We've FEA'd them, done this, that, and the other. The team finished the event, finished enduro, and came back to us and went, nah, told you so. 3 months later, I ran into their faculty advisor who gave me some pictures. I told you so. A lesson to be learned from this particularly, I'll go back to the first wheel, is obviously, poor stress design, but one of the big mistakes that you make is you use tapered nuts into aluminium wheels. Tighten them up, raise the stresses, then you flex them because it doesn't have good bending stress, and bingo, the center breaks out. Big crash. We've seen it happen more than once. Tire abuse will hurt you. Don't overdrive and don't destroy them. Want to talk about suspension? You like that suspension? What's wrong with that? Okay. One of the things we often see is the chassis has been adapted to suit the suspension rather than the chassis being designed to suit the suspension. Time and time again we hear teams tell us that they designed the chassis first, and then they've got all these little outriggers and brackets and flexi brackets and whatever. So they may have a nice stiff chassis with lots of Newton meters per degree of stiffness or whatever, but as soon as you bolt the suspension on or whatever, it all just turns into spaghetti. We really say that designing the chassis is an exercise in joining the dots. When you put into your 3D CAD program all the points, all the three-dimensional points that you have to do, be they designated by the rules or designated by the rules of physics or the size of the driver, per se, the 95th percentile or whatever, there's got to be a steering wheel in there, there's got to be an engine in there, there's got to be so on and so on and so forth. You end up with hundreds of points in three dimensions in the thing. And it literally is almost a join the dots exercise to design the chassis. Not an exercise of here's the chassis and now we're going to build some suspension on it. And that's what we see time after time. Handling history. Those who don't learn from history, what happens to them? What happens to them? Sure do. Those who don't learn from history, what happens to them? Sure do. Okay, the design devil's in the detail. I'm going to show you a couple of slides coming up now, and they're two cars of recent history. There's no pointing fingers or whatever here. Both of these cars have competed at this event in the past. Two very similar rear suspension designs. I want you to look at the two slides, and then we'll explain to you why. One is, from the judge's perspective, a much better solution than the other. The first one we'll look at is the rear suspension on the car from the University of Queensland, the car that won the dynamic events here 3 events ago. The first one was student event. As you can see, it's a push-rod car, rockers onto shock absorbers that are mounted down on the chassis. Second car is the Helsinki car from a few years ago. Again, push rods, pushing rocker arms that feed down to the chassis. Essentially the same, but not in the detail. If we look here, you'll see that firstly, the bell crank is pivoted on a pedestal which is mounted part way along an unsupported tube. Secondly is, the other end of the spring is supported on the chassis down here somewhere. Now let's go back and look at what Queensland did. Queensland pivoted their bell crank right in the node, and they fed their shock absorber load right down into the rear engine mount. Subtle differences, but subtle differences are what pick you out from the crowd. You got a comment on that?
No, you've got it covered.
Okay, what do you guys think of this design? Anybody want to critique that? Anybody recognize what it is? Okay, you're talking about this rod end here? Okay, that's a rod end in bending, isn't it? It's not really a big deal, because it's not the rod end that carries the load, which is this one up here, but it certainly is a rod end that has to react to brake torque. Brake torque around the front spindle in a maximum effort stop is the biggest single force in the whole car. Okay. Other than that, it looks okay. We wouldn't look twice at that. But they did. What's happened here is not that the rod end is broken, but in fact that the end of the wishbone is broken out. If you look there, you can see that it's actually had a failure here. You can see the brake here, and what's left of the wishbone there. What do you think it caused that? 4130 A-arms that haven't been normalized? You got it.
4130 was created back in the 1910, 1920 era for use on fuselage for biplanes. The aircraft designers learned early on that when they welded 4130, it had stress risers in the weld, and they cracked.
One of the teams here had a piece of structure from a Pfizer Storch World War II aircraft. I don't know which team it was had that, but it was an interesting multiple joint from this type of tube. Another reason why I've shown this picture is so that you get some idea of the amount of torque generated in the front brake. When this thing braked, it literally tied the entire front suspension in knots. Fortunately, nobody was hurt, but it's a good exercise. You go back and look at the first one, really doesn't look too bad. Okay, not perfect, but doesn't look too bad. Okay. Chassis. Anybody know what that is?
It's a famous race car.
Very famous race car.
Any guesses? From the mid...
A Type 61, that should give you a tip. What's this about learning from history? That's a Maserati birdcage, called a birdcage for obvious reasons. Overlapping tetrahedral, a lovely idea for a space frame, but how the heck would you fix that? How would you build it in the first place? You must be able to build it economically. You know, load paths are hugely important, overlapping tetrahedrons is hugely important. It's got all of those. How the heck are you going to build that car? There's another car from it. The reason why there are so many Australian pictures here, by the way, is not just that I come from there, but that I have permission from the teams to use this stuff, so it's fairly easy for me to do it. That's the simple, straightforward space frame from the famous Stumpy. The Stumpy was the 2003 University of Wollongong World Championship car, the first foreign car ever to win the event in the US. Straightforward, nice tetrahedron, straight lines, good load paths, well worth looking at. Now, you might ask yourself, why is Pat talking about space frames and not carbon fiber chassis? Surely carbon fiber tubs is the way to go. What do you think?
All the Formula One cars use carbon. All the
Must
Indy
be good.
cars use carbon. A lot of cars use carbon.
Must be good.
Must be good.
What one design? What was second in design? Yeah, here.
Let's just talk about how many space frame cars were in design finals.
Thanks, Rudy.
Yeah.
How many were there?
There were four.
Yeah.
4 space frame cars in the design finals, so it can't be that bad, can it? Unless we're all wrong.
What are the benefits of a space frame chassis? There are many benefits on a space frame chassis. First of all, you can build it easy. Secondly, you can fix it easy. Thirdly, you can visualize the load paths. You can see where it goes. But more importantly than that, when you sell this thing to this supposed customer, the average weekend autocrosser, how does he fix it? If he doesn't have an autoclave and all the other things to lay up and repair the carbon, like carbon is great stuff for race car chassis, but these aren't race cars. These are engineering exercises for students. I think you could bring Stumpy out of retirement today and make him meet a few rules, and you'd probably still win with Stumpy, even though that's from 2003. That's a 5-year-old car. Okay, aluminium honeycomb aluminium monocoques, easy to make, easy to build. I know of a team who actually built one of those from woe to go in 2 weeks. Good solution. Hybrid chassis, you know, carbon and a space frame. That's another solution. But having built this chassis, obviously we're going to start talking about torsional stiffness. Exactly how much torsional stiffness do you need? Do you need the car to be as stiff as a brick with thousands and thousands of Newton meters of torsional rigidity like a Formula 1 car? What do you think, Jeff? Jeff, structural engineer. This is Jeff Goddard, another one of our friends, the famous Cosworth engine designer.
Basically, Formula 1 car has to be as stiff as a brick because each wheel is carrying over a ton of download. So the spring rates on each corner are enormous, and you have to take a multiple of spring rates to decide what's stiff relative to that. So Formula 1 car, stiff as a brick. What are your spring rates?
What, 5 or 6 times the spring rate is? And then you run into the law of diminishing returns. You start to add weight and add stiffness and add complexity and add difficulty of manufacture for no real gain. No real gain. Okay. Another issue with student-built carbon fiber cars that the judges have a little bit of concern about is this sort of thing happens. That sort of thing can hurt people. We have had chassis totally delaminated and had to be withdrawn from the competition. I've seen designers sitting down crying because they were told to go home unfixable. I've also seen chassis designers upset because they had to weld in more tubes or cut some tubes out and weld them in, but they had a situation or a situation they could solve. When they'd made an error in the carbon chassis, they were gone, dead in the water, all over Red Rover. What about brakes? What are they there for? Them some brakes.
Sizing your brake system starts with a very simple formula. Figure out what the maximum velocity that your vehicle is going to be designed for, calculate the projected weight, and figure out the kinematic load. Size your brake components accordingly. There's all too many times we see brakes that are just too small in size because students don't understand kinematic loading. You take a very small lightweight rotor, you build it out of the wrong material, you lighten the hell out of it with a lot of holes, a lot of lattice work and whatnot. It just reduces the mass of the rotor, and it's going to be failed. It's doomed to failure. Size your brake system according to the maximum vehicle speed and weight of your vehicle. It's that simple.
You reckon that's right, a brake force of approximately 12 kilos per G?
That's a good number for me. It would work.
What do you think, Ruben?
It's not too bad.
Okay, anybody ever calculate that sort of stuff? What about the motion of the pedal? There isn't one chassis designer or suspension designer here who won't talk about rising rates and falling rates and sideways rates in their suspension. What about the pedal rate? Do you think a rising rate, a falling rate, a linear rate? What sort of thing do you think you need in the pedal? There was some discussion of this on the SAE forum recently. No comment? Tell them.
Rising rate, it's got to be.
Got to come up, and when the force is perpendicular to the master cylinder is when you're at the peak. What about flexi pedal boxes?
What about flexi pedal boxes? You don't like flexi pedal boxes?
Oh, I love flexi pedal boxes. They really confuse me when I'm braking hard.
They look nice though.
Oh yeah, especially with all that filigree aluminium work. Yeah.
Oh, yeah.
don't make flexi pedal boxes.
You've got to have a firm brake pedal in order to have firm control of your car. It's that simple.
A falling pedal ratio, that's why I put it down there, I think we need to discuss it. A falling pedal ratio confuses the driver. We watched drivers brake out there and decided they really weren't very good. You want to do a fast lap time, you have to get onto the straight as fast as you can, and you have to hold that maximum velocity for as long as you can. When you get to it inside of the point where you want to stop, you then need to get on the brakes firm and hard and decrease the speed in as short a period of time as possible, down to exactly that you want to slow down to, okay? If the pedal is going away and mushy, the driver just cannot do that. Must have good pedal feel. Flexible brake lines and all that sort of stuff.
Flexible brake lines are good at 4 places on the car. If you've got 4 rotors, you've got to get the brake lines connected to the rotors when they flex with the control arms. Otherwise, you should be using steel tubing throughout the car. If you don't have rigid steel tubing, you're using flexible lines throughout the car, you're just flexing lines. It's just extra mush in the brake pedal. It's that simple.
It even gets to the point where, you know, Claude sometimes asks questions about the coefficient of expansion of your brake pad material. Now that might sound very esoteric or way out there, but a good driver with an excellent brake system can most assuredly feel the coefficient of expansion of the brake pad material. Is this not correct, Claude? Where is he going? Dr. Wolf. Okay. Okay. We mentioned before that the brake tool.
Show and tell, we have show and tell. Okay, when I walked over to Torino, out on the endurance track, the driver assured me that they had a small oil leak. What he's just handed me is half of a rod.
Half a Conrad.
Finishing endurance is
Yeah, I've
the
got a slide
important
for
part.
I've got a slide for that a little way. Okay, good question. Single, multi, naturally aspirated, forced induction, E85, gasoline. What's the best solution? They all are. All of them can be made to win. Don't ever forget though, this is a handling competition. What cooling this engine? If you were an air molecule, would you go through that radiator? Or would you slide over the top?
What path does an air molecule take? The path of least resistance.
What about that one? If you were an air molecule, where would you go? You get into that duct and where do you go? Out through the hole. Who wants to go through a hot, horrible radiator? What happens in the radiator? Why doesn't the air want to flow through the radiator core? What actually occurs between the air and the radiator to cool the engine? The heat, what's the heat flow? Which way does it go? It goes from the hot water through the radiator into the air. Heats up the air, correct? What happens there when you heat it up? It expands. It makes this big bubble of expanded air, and it just wants to go around the outside. That's not so bad though when you compare it with this one. Why on earth would you do that? There's a team who've gone to all the pains to build a lovely duct and system. And what have they done? Stuck the radiator in sideways. They probably didn't finish endurance because it bore the dry. Why would you do that? What about this solution? That one will keep cool, won't it? It also adds about 20 kilos of mass hanging out behind the axle, which does wonders for your polar moment of inertia.
Oh, that's a new term. What's polar moment, Pat?
It's something to do with the North Pole, isn't it? A clock, let's see, a clock, a moment at the North Pole.
Oh, okay. If we drive a pole right through the CG of the car vertically, that's its polar moment. You want to stick all of the accessories for the car as close to that polar moment as you possibly can. It reduces the polar moment of the car and makes the car turn in faster. It's that simple.
Also makes it straighten faster when you stop turning. And polar moment has a lot to do with lots of things out in the car. Is polar moment important inside the engine, Jeff? Oh yes, oh yes. Okay. Cooling history. Those who don't learn from history are doomed to repeat it. Now, This isn't a bad example. This is actually a better example. What we've got here is a Mustang P-51 fighter aircraft, probably the best piston-driven aircraft, fighter aircraft in the Second World War. And this aircraft had a secret weapon. For some reason that people didn't understand, this aircraft, powered by the same engine as the Spitfire, at about the same weight as the Spitfire, could actually fly farther and faster, because a very clever gentleman had determined how to use the cooling duct as a low-level ramjet. So they bring the air in, heat it in the radiator, and then expel it through a variable duct here, which actually allowed the aircraft to almost coast on its own waste heat. Now we have the team from Beirut. A duct closed, and a duct open. Okay, their solution is more about controlling the airflow through the radiator, but that aircraft first flew in, I think, 1942.
Yeah.
And let me tell you, Jeff will tell you, he's from aerospace, the trick was about a lot earlier than that.
Yeah, I mean, just making use of natural effects like that, simple physics, is important. On a Spitfire, if the enemy were behind you, you had to shut the radiator duct and give it full boost and hope the engine didn't blow up. That was your getaway plan. On a Mosquito or a Mustang, you opened the duct, because that gave you more boost.
Yes, you were using the energy from the heat. And there are solutions. That's what we talk about when we talk about innovation or clever design or whatever. Drivetrain, your business is drivetrain. You want to talk about drivetrain?
Drivetrain is simply the act of getting the power that your engine makes down to the ground. All the power that you have in the world is no good unless you get it to the bottom contact pad to the rear tires.
Did any team today have an axle that looked like that?
Any failed half shafts today? I know of at least one.
Why would a half shaft do that? No.
Overextended flexing.
And when you apply the torque and try to send that torque around a corner, it tries to straighten itself. So when we hear teams who run drive shafts around angles like this and say, oh, but the manufacturer says up to 10 degrees is all right, the manufacturer doesn't mean that it's all right to run it at 10 degrees all the time. The manufacturer is really saying to run it straight, however, an occasional deflection of up to 10 degrees is acceptable. You drive them around a corner like that all the time and you're going to end up with failures or bent half shafts or whatever. Is this...
Absolutely.
Anybody ever lowered a car, a rear-wheel drive car, and found that it shut the daylights out of it because the tail shaft was now had harmonic balances? Same thing. You change the angle between the nose of the back of the gearbox and the nose of the front of the differential. The angles changed, and these harmonics proceeded to shake your car to pieces. Still in balance, but you can't get rid of all these natural forces. All these laws, Ohm's law, Newton's laws, Kirchhoff's law, Pascal's law, and so on, they have not been repealed. They're still as valid today as they were 500, 10,000, 100,000 years ago. You cannot repeal the laws of physics. Can't happen. Is that a likely occurrence? Does one go from there to there with some simplicity? What about this solution? Oh, that solution. That's, I mean, there's a drivetrain, chain alignment. T.U. Gratz here, can they tell me about chain alignment? T.O. Gratz, the other Gratz, Todd Gratz. What about that? That looks like good engineering to me.
That's a lot of bolts to be transmitting the amount of torque that's going through a half shaft.
What about that solution? That's got the rubber donut on the outside end of the half shaft.
Well, the original equipment manufacturers use that. It must be great for a Formula student car, right?
Well, it's all right on the inside, perhaps, but on the outside, the half shaft can do this. Proceed to wipe your suspension out. What about flex plates like that?
That's an aluminum flex plate.
with a carbon fiber axle. There's actually a stainless steel flex plate in here.
Oh, okay.
Yeah. Make your own mind up. I wouldn't use them, would you?
No. Doomed to failure, GTB. What's GTB?
Going to break. Okay. No one likes tatty wiring, waterproof connectors, simplicity, wire size, and all that sort of stuff. How would you like to be troubleshooting that one? Or that one? Your wiring should probably look a little bit more like that. Sanitary table, tidy up, out of the way, easy to fix. I would think electrical problems, probably more than 50% of the electrical problems that you're going to have are all to do with bad earths. You know, high resistance in the ground connection or whatever. Okay, let's talk about some ergonomics history. Doesn't fit it very well, does it? Those who don't learn from history are going to repeat the mistakes, aren't they? Do you think that's the truth? Of course it's the truth.
Anybody recognize this competitor? Is Frank in the room? Too bad.
Frank's busy. And that's the very first Tokyo Denki car, which was a very small car, and Frank physically just couldn't get into the motor car, and it was too good a picture opportunity to pass. However, Frank can get in some motor cars. Okay. While we're talking about ergonomics, we'll talk about some of the rule changes for the coming year. Not with this competition, but with the other competition I'm involved with, the Australian competition. I am a party to the Rules Committee and the Rules Committee decisions. And I've noticed that there's been a flurry of correspondence from German teams in particular, almost as though it was pre-arranged, not that that would happen, complaining or protesting to the Rules Committee about the rules for next year, about the football templates. Anybody here belong to a team who've told the Rules Committee in the US that they don't like this? Most of them have. Okay. Why do you think these rule changes happen? And where do these templates come from? Well, first thing I'll tell you is that the templates are the FIA Formula One templates. Your car's footwell will now be built to the same template and dimensions as anybody's Formula One car. But why do they do it? Why did it have to happen? Why do they have to change it? All your fault. Sorry, all your fault. Repeatedly, the teams will build cars. Oh, by the way, that's the new 95% mark. Okay, repeatedly you will build cars with a shin breaker rack. Those cars come to the competition. The cars get trouble getting through scrutineering. You've got to put padding around them and all sorts of weird, wonderful stuff.
It's difficult to get in them. You have to really hyperextend your foot to get into the foot box.
Yep.
What happens if it has a frontal collision, Pat?
Well, we'll show you some frontal collisions in a minute. Now, we repeatedly ask not to do that. When the car comes to design, let me promise you this, no car with a shin breaker rack is ever going to be in the design finals. And yet, despite that happening, the teams still build the racks. Now, meanwhile, the organizers of these events are paranoid about students hurting themselves. I mean, we're responsible for you. A mistake happens. We don't want to have a situation where somebody can never walk again or they're in crutches for months. Even worse, we don't have a situation where some judge says, so let's get this straight. You experienced people in this business allowed this inexperienced student to drive that car knowing that it had the potential to smash his legs up? No way in the world. So the rules were changed because, as an example, that car is here today. That's a car that came through scrutiny this week. It's here. Okay, that's the result of Cornell crashing their car in testing in 2003. The next slide is probably better. Who would like to have been in that car with a low-mounted rack? They certainly wouldn't have walked away. You think that's an isolated incident? No way. That car was Virginia Tech's car crashing. They actually came through the fence and nailed the abutment. And that's what happened. I thought, well, how would you like to have had your feet in there with a low-mounted rack? So, sorry folks, the rack is going to either have to go up or go down so that the template goes in. Sorry, that's the way it is, and it's not going to be any different. And all the letter writing campaign is only going to get your letters back from Michael Royce like you've already got. That's to say, your objection is noted, however, the rules are already in place and that's the way it's going to be. So learn to live with it, move on, design your cars for the new rules. Another example of why the rules get changed because of your fault, not your fault, but you know what I mean, is for many years we had a crash attenuator requirement on the front of the car, but we didn't have to prove it. And then 4 or 5 years ago, this car turned up in the UK. Okay? Do you think that said to the judges, ha, we don't care about your rules, we're just going to... And instantly, now, you had an additional task. You had to prove your crash attenuation. So it might have sounded funny after a night on the booze and stick some hot glue, some beer cans on the front of the car. Okay.
Were they full or empty?
They were empty. Serviceability. You want to be able to fix these darn cars, don't you? Make the car easy to pull apart, easy to get out, easy to fix. We have, what, 10 minutes? I think we'll talk about dampers another day. Except, how did our friends with the Air Maguras go? What team was that?
I'm not naming names.
No, but there was a team here with Airshock, Magura Air Shocks.
There was more than one team.
Yeah. And literally, you could bounce the car at the back and make the wheels float off the ground.
Like on a trampoline. Doing.
Yeah, so, but however, we did notice, however, that a very great number of teams are using the Cane Creek double barrel shocks, and we would recommend to you that that is in fact the shock absorber to use. They're made by Öhlins in Sweden. They're fully adjustable on bump and rebound, high and low speed, but more importantly, everyone is the same. Generally, bicycle dampers are different because there's only one on a bike. Their job is to protect the chassis from breaking when you jump off a cliff or whatever. But the Cane Creeks do appear to be the only shocks that really do the job. We'll talk about dampers. We've got enough to fill several of these presentations. We'll talk about dampers next time. Unless you've got something to say. Okay. What about gas? You going to run gasoline, petrol, or are you going to use E85? And what's the decision? Why? I would ask you, I'm not going to talk about this much, but I would ask you to think long and hard about this, because the new rule for next year that gives 100 points for energy consumption will have a very great bearing on which fuel you choose, more so than now. E85 is, an alcohol-bearing fuel. Your stoichiometric ratios are very different. There is possibly less potential energy in the E85 than there is in petrol. You need to go back and do your sums. Currently, it's balanced pretty well with a 20mm restrictor versus an 18mm restrictor, whatever it is for E85. But think about it. You need to go back and do your sums, because the difference between 100 points for fuel, 50 points for fuel consumption and 100 points for energy consumption means that you've got some sums to do for next year. Who's got one of them? Or one of them? Anybody measure torsional stiffness? Easy thing to do. Good.
If you build a chassis, you should be measuring it for torsional stiffness.
I'll call this a cannabis car. Because to design a device like this we're into the fun and the examples end. The only way that a team could possibly sit down and design a motor car like this if they were off their face comprehensively. Okay? How does that work? Okay. The rubber pivots on here just doesn't work. You think it's funny? We see lots of them. I gotta tell you, we see lots of them. Going back to here, not only does it not work, but look. Oh dear, oh dear, oh dear. Everywhere you look on the car.
Rod ends in bending.
Rod ends in bending. But as I said, look, this sort of nonsense, even if this is running on needle rollers or whatever, that's so far out of plane, it just physically cannot work. So, how did it ever get to be built? It might work in a simulation, because they're frictionless and so on and so forth. But it got built and it got taken to a competition, and needless to say, it never ran. Okay, we might call this one an ecstasy car. What lunatic thought this was going to work? That's probably a fix to make the wrong offset wheels fix. What happens the first time you drop the clutch, Mr. Drivetrain Expert?
Twing!
Tricycle?
Oh, maybe bicycle. At least one wheel is exiting stage left.
Oh dear. Okay, what's wrong with this one? This is an interesting example. This car came up. There's lots and lots and lots of DNFs hidden in these two pictures. I've got the system assembled and disassembled. We look at the assembled one to start with, and okay. What about the rod end can pull over the head of the bolt? There's two DNFs. Don't know what's down the bottom. What we've got here, though, is an arrangement where this steering arm is bolted through into the upright. Sorry, into the upright over here, and traps the caliper. I'll go to the other picture. Okay. Okay, so these cap screws go through here, bolt into here. So first of all, they're just threaded into aluminium, no helicoils or whatever, and no way to, because the heads are countersunk, there's no way to mechanically lock them. These are critical fasteners, can't be mechanically locked. Over here, we have a stub axle which is only this length. The two bearings in the hub are right beside each other. How long is that going to last? And worst of all, the brake disc is bolted to the hub with countersunk screws into tapped holes. No way to lock them, no helicoils. Doesn't look too bad at first sight, but when you look at it, there are so many DNFs. Whoops, I'll get to that in a minute. How many DNFs do you see? So, think through, this is where these design meetings matter, where you've got to sort of talk about this stuff and sort it out. Okay, welcome to the heroin car. If we had a cannabis car and we had an ecstasy car, you absolutely had to be shooting up to make a thing like this.
But I'm telling you, we were talking about testing chassis torsional stiffness before. If you all come up next year and tell me you get 100,000 Newton meters per degree chassis torsional stiffness, I'm going to ask you what the installation stiffness is, including suspension. Yeah? This is what we're talking about. Obviously, this is bad design on top. But if you talk about stiffness, please take the suspension into account.
Yep. Replace the spring and shock absorber unit with a dummy shock, and measure the stiffness of the chassis hub to hub. Needless to say, that wasn't allowed to start. Enough horror stories. Okay, why would you do that? Here's the team recently, one of the US events, who decided to run separate shocks from the springs. Apart from increasing the complexity of the mechanism, having the springs concentric with the shocks is actually not a bad design idea. I don't know how you do that. What about that? The good, the bad, the ugly. Lovely car and wishbones with what's encapsulated. The good. The bad, about a 50mm toe base. This is one of those compliance toe specials. This is one of those cars that every time you tip the power it goes sideways because the rear wheel's steer. And I'm sure the drive shaft has come out of a combine harvester. That's no place on the car. Students do it. Gearing, how important is gearing? You're the powertrain guy, tell them about gearing.
Gearing is everything. You can have all the power in the world, but without proper gearing, it's not going to get to the ground correctly.
It's about matching. Why is this stop? It's about matching your power curve with, matching your torque delivery to the road. Here I've called this slide excrement occurs because we don't use 4-letter expletives up here, but you all know shit happens. Especially our friends from Torino. You've got an engine block that looks like that, haven't you? Do you like the guy looking from the other side? Okay, sometimes the judges are absolutely flat-footed with what happens. Here we've got a very front-level, very best car from one of the US events a couple of years ago. Can anybody see anything odd about it? Does it look like it's set up to run at Indianapolis with offset suspension? There's at least an inch difference in the track on each side of the car. Can you see that now? Look,
It's not an optical illusion.
it's
One
not
side
an
of the
optical
car-
illusion.
One side of the car is lots longer than the other.
The team didn't know about it, so we said, what's this all about? I thought maybe they had an offset center of gravity or some such thing, and they wanted to balance the car because it's a team that's smart enough to do that. But that team smart enough to do that, we're also dumb enough to do that. Okay, is that a dumb way to DNF? You want to talk about traction? Next time. What about Ackerman? How important is Ackerman? Well, there's Ackerman. Okay. What about data logging? All these things aren't new. The reason I'm showing you these old pictures is so you can learn from history. That's 1964 BRM with a, I think that's an old 2-channel analog data logger that you used to use in airplanes. Strapped on. Wonder what it did for the polar momentum. What about dynamometer tuning? How new is that? Here we have a car on a dyno in the 1920s. Why do they call them a brake? Why do they call it brake horsepower? Because in the bad old days, the wheel drove a roller which came across an axle to a brake which was operated by a man with a big lever. That's where the load came from. Dyno testing, a very good way to get your calibration done before you get to the event. Okay, how important is this? This is the clue to you not making mistakes again and again and again. And we talked about those who make mistakes are bound to repeat them and so on and so forth, those who don't read history. There needs to be in your university a foolproof way to pass the knowledge from team to team to team. I don't know what that is or how it should be, everything's different. But without it, you're going to have teams turn up year after year after year with run-ins, evading, and all those other horrors that we see again and again. You need to think about that. That's also part of the planning.
You want to pass on this legacy information that you struggled this year to learn on your own to next year's team. And you don't only want to tell them the good stuff about the car, but you also want to tell them, it's equally important to tell them about all the bad stuff, the really bad things that happen that you wouldn't want to do again either. This is called legacy information. It needs to get passed on from year to year.
That's better. I was getting a bit dry. Learning together, of course, shared information. Where do you get your bits? Go down the wreckers. Don't you? What about building your bodywork? Well, this bodywork. Carbon bodywork, no less. Composite bodywork. Okay, what about the on-track part of it? We have seen at many competitions the team completely lose the event from a winning position on the track, not because they couldn't drive, but because the excitement the excitement of the event overwhelmed them and stupid mistakes were made. We watched a car today very, very nearly DNF when the driver repeatedly stalled at the driver restart, through being excited and wanting to go and always jumpy. And each time he had to start with the battery cranked just a little bit slower. Fortunately, he got it out on the track and was able to go. But yeah, driver training is important. Go-karts are the way to do it. but obviously experiencing the car itself is also really good. Harking back very briefly to ergonomics for a second, but it comes back to the driving on the track. We watched the Delft driver today. The Delft people here? Yeah. Okay, your driver driving like this. That isn't the way to go fast. Okay, now it's time to shoot some ball. Question and answer time. Anybody got any questions? Not a question.
Everybody's happy. Everybody knows all they need to know. You've got the 3 chief design judges for Formula Student Germany sitting in front of you. Any questions at all?
By the way, if you do see any of these people around, call the cops, they're deadly. From another place and another time. We have a question. Go.
Will this be available online?
Hang on.
Will the presentation be available online at some point?
I'm pretty sure it will. The last two have.
Thank you.
Another question?
That'd be for a small sum, right, Pat?
Oh yes, I think that agrees. The presentation itself is a work in progress, so we may not release that as it is just at the moment. Obviously there's bits we skipped over, bits we'll expand. We'll do something similar next year, hopefully, but we'll make it different. Talk about other parts of it and so on and so forth. Anybody else got any questions? People starting to drift away. You got anything to say, Jeff? Any final words?
Well, just reinforce what Pat says. Any engine can win this competition. So for the team starting out, you don't have to spend a fortune on your engine. Get your car sorted, get the engine running, and go and really compete. And you'll find you'll do amazingly well. For those who've got the budgets and the time and the manpower, yes, you can start playing engine research and discover a lot of things that you either didn't know, or you can start reinventing the accidents from history, as Pat said.
Thanks, Jeff. You got anything to say, Rudy?
I think we got one more question just up there. I just noticed that in the design template for the cockpit space, there's a cutout in the top for high-mounted racks. Will there or will there not be a cutout in the bottom to accommodate low-mounted racks, or how does it work?
Ask Michael Royce. Honestly, I don't know. I haven't actually seen the templates as yet. I just know what's going to happen. We're going to have to learn to deal with it. When the final draft of the rules popped into my email box earlier this week while I was here in Germany, with a couple of slight modifications, and the rules committee will judge on, will vote on that in the next. Well, maybe they already have voted on it. So the rules will be posted on the American FSA site, like not FSA.com, but the Formula SAE site, the SAE site in the UK, probably very soon. Then we'll know, you'll be able to make your own templates and do whatever you're going to do. You have a question? Any other questions? Okay, I'll just hand over to Rudy. Oh, we have one.
Earlier on you talked about you want the energy consumption, 100 points for energy consumption, additional to 50 points for fuel economy. I didn't quite get the point of energy consumption. Could you explain that?
It's not additional to the fuel economy, it's instead of the fuel economy, and it's 100 points which will be awarded for energy efficiency. The details of this will be released in due course. We just talked about what's going to happen. We do have a plan for how it's going to work, but you'll get those details in plenty of time to plan for next year's competition. Incidentally, that's only for Formula Street Germany. That's not an overall rule. No more? Nobody from this side? Who's had a good weekend? Oh, you have a question. Come forward, please.
I was wondering how important you find single wheel frequencies in a coupled system.
Single wheel frequencies in a coupled system?
Yes.
A question for another place and another man.
Come to the semi
Why?
Because it's far too complex.
There was what I was about to say. There's a seminar starting tomorrow, just over there,
Yeah.
and I'm sure you get this question answered.
He
It's
says
20.
he says he's going to the seminar.
Okay, make sure you ask Doug. Look, it's 20 minutes to 10. Everybody's hanging out for a beer.
Oh, no.
We're not going to start talking about complex wheel frequency issues,
We have to hand out some awards first, Pat.
do we?
Yes, that happens first in the marquee. So without further ado, I'm Steve Fox.
I'm Rudy Dietrich.
And I'm Pat Clark.
Thanks very much for being here.
And
We
remember,
enjoyed it a lot. I hope you learned a bit and had a bit of fun. We learned a lot and had a lot of fun. And maybe see you out there having a beer, okay?
and remember,
Thank you very much.
the trick is, there is no trick. Good night.